These are the practice problems for Lesson 5, solving any linear equation. And in this first problem, you're given 3 problems to solve. And it just says, solve each of these equations, explain or show your reasoning. It does not say to check your answer. You might want to do that anyway. So in this, if you just look at each of these 3 problems and jot down some notes about how you're going to solve them, it starts to make some sense. You see some parentheses here. It means you have 2 groups of something. So the first thing you're going to want to do is use the distributive property. Basically, take the x and the 5 out of those 2 groups. So you're going to distribute this 2 to the x and distribute this 2 to the 5. In this problem, you're going to then use the additive inverse to move the x's around and move the numbers around. But in this problem, interestingly, you're not going to use the multiplicative inverse. See if you can tell why that is without solving the problem. In this problem, you're going to use the additive inverse. There aren't any parentheses or anything, so you use the additive inverse to move the y's around and the numbers around. You are going to use the multiplicative inverse because you're going to end up with y with a coefficient. And that coefficient is going to be 5. Can you tell why that is before you even start to work it out? This one, the distributive property, you need to take the n plus 2 out of the 3 groups. So you're going to end up with 3n, and 3 times 2 is 6. And likewise, here's the same thing. You might want to change this to adding a negative n so you don't get confused. So this is going to be a negative 9n. This is going to be a positive 3n. So the coefficient of the n in this problem in the end is going to be 1/12. Can you tell why that is? All right, so let's work through these. So this one, using the distributive property, you have 2 groups, x plus 5 in each group. So that means you have 2 x's and you have 2 5's, and you're going to end up with 3x plus 1 on the other side. So 2x plus 10 now, 3x plus 1. You want to get rid of this 1 by adding the additive inverse. So add a negative 1, this becomes 0. Add a negative 1 here, this becomes 9. And at this point, you can tell that x equals 9 because look what you have. You have 2 groups of something plus a 9, and then 3 groups of that same thing. Well, if x is 9, that means you have 2 groups of 9 plus another 9. That's 3 groups of 9. And over here, this is 3 groups of 9. So 9 is equal to x. You add a negative 2x right here. Negative 2x right here, you end up with 9 equals x. And up here I could tell because I had 3x here, and I knew that this was going to be 2x. And I know that I'm going to move the 2x over to this side as a negative 2x because I'm going to add a negative 2x here, add a negative 2x here, so this is going to become 1x. So that's how I knew that this would not have a coefficient. The next problem, 3y minus 4 equals 6 minus 2y. And I would change this to adding a negative 4 and adding a negative 2y first, right here. So change, this is subtracting a positive 4 and subtracting a positive 2y, and use the additive inverse. Add the additive inverse. So add a negative 4 and add a negative 2y. So that turns these into addition and adding a negative term. All right, so now, let's see here. I'm going to get rid of this negative 2y on this side, so I'm going to add a positive 2y. And this is how I knew that this was going to be 5. The coefficient was going to be 5. Because up here, this is 3y. And this is, I know this is going to become a negative 2y because I'm going to change it right here. So then I'm going to add a positive 2y to get rid of it, add a positive 2y here. So this becomes 5y. So I'm going to use the multiplicative inverse to get rid of that 5 pretty soon. Move the negative 4 over to this side by adding a positive 4 and adding a positive 4. You're not really moving the negative 4, but you're moving this term. You're getting rid of this term, and it's going to show up on this side as a positive 4. So add a positive 4, add a positive 4, 5y equals 10, and y equals 1/5 of 10. So 1/5 of 5y gives you 1y, and 1y is going to equal 1/5 of 10. So 1/5 of 10 is 2. 10 divided by this 5, or 1/5 of 10, is 2. So y is equal to 2. And here's a little note on how to do that, how to simplify 10/5. You can factor the 10 into 2 times 5, and that's divided by 5. And remember that 5 divided by 5 is 1, so you're left with that 2. Over here, it's 1/5 times 5 becomes 5 divided by 5 equals 1, or you can just say that 1/5 of 5 is 1. It's a little note of how that actually can work as far as you're actually doing this multiplication and ending up with 5 over 5, and that equals 1. The last problem, I said that you're going to end up with a coefficient of 12, so you're going to want to multiply with the multiplicative inverse of 1/12. So let's see how that works. So you're going to end up with 3n here and 6 here, and you're going to end up with 9 times 6 is 54, plus a negative 9n here. So plus a negative n times 9 is a negative 9n. So here's the 3n, here's the 6, the 54, and the negative 9n. And I said it's going to end up with a coefficient of 12 because I could see right here that this is going to become a negative 9n. You're going to add 9n to get rid of it, add 9n over here, so this is going to become 12n. So 3n plus the positive 9n, you're adding 9n here to get rid of this negative 9n, so this becomes 0. So you end up with 12n plus 6. So 12n is equal to 48. You're going to end up with, you're going to add a negative 6 here, a negative 6 here. So 12n equals 48. And so therefore n is going to equal 1/4. 1/4 of 48. I'm sorry, n is going to equal 4. 1/12 of 12 is 1n, and 1/12 of 48 is 48 divided by 12, or 4, not times 12. All right, again, I could see that this was going to become 12n. This is a negative 9n, so 9n plus this 3n becomes this 12n down here. And you want to look at 1/12 of 12n, which means that's going to equal 1/12 of 48, the same fraction of 48 as the same fraction of these 12n's. So n equals 4. Here it is all together. So you can look at it on a single page. You might just work through it in your head. Make sure that you understand each step. In problem number 2, it says that Claire was solving an equation, but when she checked her answers, so when she took negative 77/29 and replaced y with that value, she got a different amount on the left side of the equation than from what she got on the right side of the equation. So her answer didn't check. Her solution was incorrect. So she knows she made a mistake, but she can't find it. So where is Claire's mistake? And what is the solution to the equation? Well, it turns out that Claire made 2 mistakes. So when I look at these problems, I'm going to always change this to adding a negative. And this is a positive 1 right here. You're subtracting a positive 1 group of this. So if I change it to adding a negative 1 group of this and adding a negative 9, it's going to limit my confusion when I work through this. So this is the opposite of 5 plus a negative 9y. So I added the additive inverse of a positive 1 and added the additive inverse of a positive 9. So this is a negative 9y, and this is negative 1. Likewise, down here, if you look at this as the opposite of what's inside this group, so it's the opposite of a positive 5 is negative 5, and the opposite of a negative 9y is a positive 9y. So this is where she made her mistake. She said this is a negative 9y, or she said subtracting a positive 9y. So you go back to here. The problem is you cannot distribute an operation. You can't distribute subtraction. There's no property that says, oh, distribute subtraction. The property is the distributive property. You have to distribute a factor. So oftentimes teachers will say subtract the 5, and you subtract the subtraction of the 9y, and you immediately run into problems because that language is confusing. So if you change this to adding the additive inverse, so adding a negative 1 times this amount and adding a negative 9y, you will no longer have that confusion. It's obvious that this is the opposite of 5. So it's a negative 5, and the opposite, or a negative 1 times a negative 9y, is a positive 9y. So this is where she made one mistake right here. It's the wrong sign. It should be a positive 9y. Her other mistake is over here. 5 times 12 is 60, not 72. 6 times 12 is 72, but this is 5. So 5 times 12 is 60. So this is the other place that she made her mistake. So now you just work through that. So this becomes 60, and this is 13. So this is a positive 9y plus 4y is 13y. I can't remember what she had there. It's not negative 5y. It's a positive 13y, because this is a positive 9, not a negative 9. So now I'm going to move this 60. I'm going to get rid of the 60 and add a negative 60 to this side. So I'm going to add negative 60 to get rid of this 60, add negative 60 to this side. This is going to become negative 65. And then I'm going to want to remove this 13y by adding a negative 13y to this 24y here. So add a negative 13y, add a negative 13y. So 24 plus a negative 13 is equal to 11. So this is 11y right here. And we still have this negative 65. Get rid of this 11 as the coefficient by multiplying by 1/11. You want to look at 1/11 of 11y's. You want to look at that same fraction of negative 65. So it's 1/11 of negative 65. So y is equal to negative 65/11. This is a tough answer to check. It's a weird fraction, but you want to leave it as an improper fraction. Do not change it to a mixed number. Leave it as a negative 65/11. And replace y with negative 65/11, this y with negative 65/11. Remember, this is multiplying, this is a negative 1 times what's inside the parentheses here. So this is adding a negative 9 times a negative 65/11. So these numbers are tough. There is no way around dealing with this difficult fraction in an easy way. My advice is to just leave it as a fraction and work with it. So use a calculator and multiply negative 9 times negative 65. You get 585. And notice this is a positive 585/11. It is the opposite of 9 times a negative 65/11. Well, the opposite of a negative value is a positive value. And I haven't done anything else over here. Oh, right here. You have to multiply 2 times negative 65/11. Because this is two groups of this negative 65/11. So you get this answer right here. So working down here, 4 times negative 65, get negative 260. And so now we're going to look at the opposite of what's inside these parentheses. The opposite of a positive 5 is negative 5. The opposite of a positive 585 is a negative 585. And down here, you have to multiply this 12 times negative 130/11. This means that there's 12 groups, or 12 of these things. You cannot add 60 plus 12 first to get 72, and then say, now I'm going to multiply 72 times this. You have to do this multiplication first, because this goes together. All multiplication goes together. You have to do that first, and then add the 60. So 12 times this negative 130 is going to be way down here. And then I'm going to add 60 to that. And on this side, this is just all addition. So I'm going to add these two fractions together to get a negative 845, still plus a negative 5. All right, so I have a negative 5 here, and I'm going to end up with 60 over here. And to add those, I'm going to change those to 11s. It's kind of, it's long and involved. So to add negative 5 to this fraction, I'm going to change this to negative 55 11s. You multiply by 11 over 11. So now I can add these together. Just use a calculator, add them together. Oh, actually, let's stop here for a moment and add this 60 to this fraction by changing this to 11. So multiply by 11 over 11. That's 660 11ths. So now I have everything in 11ths. And it's all addition, adding, and adding. So I can multiply through by 11. Multiply each term by 11. You're going to get the numerator. Multiply each term by 11. And now add those numerators together. This equals a negative 900, and this equals a negative 900. This is tough. I would talk through it once again. Just go through and make sure you understand each step. You can look at this step right here as just saying, well, I'm going to just add the numerators. I'm going to forget about the denominators. And so this would become a negative 900 11ths equals a negative 900 11ths. Or you can multiply through by 11 and say, I'm just going to work with the numerators that way. A couple different ways to work with that. In problem number 3, you have 3 problems to solve, and it says check your solution. And just look at this first problem here. You can use the distributive property, but then you would be multiplying by fractions. It's a little bit tougher to do, so you might want to multiply through by 9 first. So 9 times 1/9 and 9 times 1/3. In the second problem, I'm probably just going to use the distributive property. Remember to change this to adding a negative 2r. And in this problem, this becomes tough. This is where you're subtracting a group of something, and within that group there's a subtraction. Remember, you don't distribute subtraction. You distribute the 1, that's the factor, and it's best to change that to adding a negative 1. So change this to addition. This becomes a negative 1, so it's the opposite of this. Remember to change this to adding a negative 9y. So just a quick overview. So let's just go through these in detail now. So the first problem, change the subtraction to addition. So adding a negative 16. Multiply through by 9. So 1/9 times 9 is equal to 1. So that's one of these groups is equal to 3 of these groups. So 9 times 1/3, or 1/3 of 9 is 3, or 9 times 1/3 is 9 divided by 3, still 3, however you look at it. So one of these groups, once again, is equal to 3, this right here, 3 of these groups. It gets down to here. So this one group is equal to 3 of these groups. And so now you can distribute the 3. So you have 3 of these groups. So that means you have 3 2m's for a total of 6 m's, and you have 3 4's for a total of 12. So it's 2m plus a negative 16 still on this side. And then you can 2m plus a negative 16. And then you can get rid of the 2m here by adding a negative 2m. You want to do this side. You want to get rid of the 2m on this side rather than the 6m on this side, because that will keep the m's positive. So you're going to add a negative 2m here and add a negative 2m here. So that's now 4m is the total number of m's that you have. And you're left with a negative 16 and a positive 12. I wrote this is plus a negative 2m, and then right here plus that positive 12. So now you want to move the 12 over to this side, so subtract. So add a negative 12 add a negative 12 here. This is going to become a negative 28. This is negative 28 equals 4m. Well, 4 times what number equals 28? 4 times 7 equals 28. So you want to look at 1/4 of 4m. You want to look at 1/4 of a negative 28. 1/4 of a negative 28 is negative 7. So m equals negative 7. So remember, you have to keep this portion, this ratio, the same. This fraction of 4m is the same fraction as negative 28. That's why you multiply it by 1/4 on this side and 1/4 on this side. 1m equals negative 7. So you take that negative 7, you replace the m in the equation with negative 7 to check. So you work through this arithmetic. So here you have negative 14, and here you have negative 14. So negative 14 plus negative 16, negative 30. This gives you negative 10 right here. So 1/9 of negative 30 equals 1/3 of negative 10. Not an easy fraction, or not easy fractions to work with, but you don't have to get to a final number. Oh, actually I do here. So write this as the opposite. So pull out that negative. You can pull that out as a factor. So this is negative 1 times 30. So negative 1 times 3 times 10 over 3 times 3. These 3's cancel out, and you're left with a negative 10/3, a negative 10/3. And on this side, this is 1/3 of negative 10. So again, factor out the negative 1. So negative 1 times 10, that's this right here, the opposite of positive 10. So negative 1 times 10 divided by 3. So again, you have a negative 10/3. So negative 10/3 equals negative 10/3. So this equation checks. This solution checks. The next problem, so here's the whole thing written together. The next problem is this one here. And so it looks like we're going to use the distributive property a couple times. So I'm going to factor out the negative 1 here. So this is a negative 1 times 4 times r plus 2. And 4 times 2 plus a negative 2r. So I'm going to change this to addition, adding the additive inverse of a negative 2r. So now we have the opposite of negative 1 times 1/4 of 4 and 1/4 of 4 on this side. So we're multiplying through by 1/4 to get rid of that 4. So actually we're not using the distributive property. So now we have a negative 1 of this group. So remember, 1/4 of 4 is 1, and it's a negative 1 of that. And 1/4 of 4 is 1, but it's 2 plus a negative 2r. So this is the opposite of this group. So that means it's the opposite of r, which is a negative r or negative 1r, and the opposite of 2, which is negative 2. So now we have to get the r's on the same side and the numbers on the other side. So we're going to add a positive 2r. That's going to make this a positive r on this side. So add positive 2r here. So negative 2r plus a positive 2r, this becomes 0. Add a positive 2r here. So positive 2r plus a negative 1r, a little bit hard to follow. This equals 1r here. This equals r. So r is going to equal how much? I'm going to add 2 here to this 2. So r should equal 4 if I'm looking at this correctly. So 1r plus a negative 2, add 2, add 2. So r equals 4. Now to check that, replace this r up here with 4. So negative 4, 4 plus 2 is 6. So this is a negative 4 times a positive 6, the opposite of 4 times 6 on this side, and 4 times 2 minus 2 times 4. So there's the negative 8, and here's the 2 plus negative 8. That's equal to negative 6. So you have 4 times negative 6, and that factors to 4 times negative 1 times 6. So it actually equals negative 24. So this side equals this side, so that problem checks. And so here it is all together. And the last problem. So I started working through this problem, and I just thought this problem seems familiar. I think we've already done this problem. So using the distributive property, 12 times 5 plus 12 times 2y on this side. Remember, that's a positive 1 here. So if you change that to adding a negative 1, so adding the additive inverse, and that negative 1 is what gets distributed. And remember, this is adding a negative 9y. So adding a negative 9y. So change this to addition, add the additive inverse. So you work through this, 12 times 5, that's 60. 12 times 2, this is going to give you 24y, 4y. This just seems familiar. So the opposite of 6 is negative 6, and the opposite of a negative 9y is a positive 9y. So continue to work through it. This is 60 plus 24y. This is 4y plus 9y is 13y plus negative 6. And you get down to here, add a negative 60 here to get rid of this 60, add a negative 60 here. This is going to become a negative 66. So now we have 13y plus a negative 66 equals 24y. Add a negative 13y to get rid of this 13y. This becomes 11y right here. And that's going to be 11y is going to equal negative 66. Haven't we done this? This is 11y equals negative 66. So 1/11th of 11y is going to give you 1y. And you have to look at that same fraction of negative 66. So this is a negative 66 elevenths. Well, 66 is a multiple of 11, so you can factor out this 11. So this is a negative 1 times 6 times 11. Those 11s cancel, and you're left with y equals negative 6. So I went back and looked at previous problems, and this was problem 2. So you get down here to negative 65 elevenths. In this problem, you get down here to negative 66 elevenths. So what's the difference? What's the difference between this problem and what's the difference between this problem once we corrected it? So remember we had to make these corrections here. So it's really this problem right here. And the difference is this 5, which turns into this negative 5. So it's this 6, which turns into this negative 6. So when you add negative 60 plus this negative 6, you get negative 66. In problem number 2, you added negative 60 plus a negative 5, you got negative 65. And then you figured out that this was negative 65 elevenths. So y equals negative 65 elevenths. In this problem, this was negative 66 elevenths. So y equals a negative 66 elevenths. So it's interesting. The problem seemed familiar. It was just this one little change here, changing this. It was 5 in problem 2 to change it to a 6 in problem 3. And just that one little change made this solution much easier because you ended up with a multiple of 11. Whereas in this problem, 65 is not a multiple of 11, so you just had to check it with this negative 65 elevenths, which is pretty tough. Now check this problem with y equals negative 6. So plug in the negative 6 and work through the arithmetic. So 2 times negative 6, 12 times negative 12, so negative 144. Add those together, you get negative 84. On this side, 9 times negative 6, so you have to add a negative 9. So a negative 9 times negative 6 is a positive 54. The way that I look at that is the opposite of 9 times negative 6. 9 times negative 6 is a negative 54, and the opposite of that, that's negative 1 right there, is a positive 54. So 6 plus a positive 54 is 60. And then the opposite of that, so I'm just continuing to work down this side right now. So the opposite of 60 is negative 60. And this side I haven't touched at all yet. So this is negative 24, negative 24, negative 24, negative 24. And so when you get down to here, negative 24 plus negative 60 is negative 84. So that answer checks. So just focus on this side, work within these parentheses until you get down to an easy number, which is 60. and then the opposite of 60. Remember, this opposite, this -1, comes from changing this to adding a -1 times this amount. So there's lots of little things to keep track of. Here it is all together on a single page. And again, I would just work through each of these, talk through it, make sure that you understand each step, what's going on. Try to remove any confusion. For problem 4, says here's a graph of a linear equation. So this is a linear equation. This is the graph of that linear equation. Select all the true statements about the line and its equation. So the first thing to do is just to plot these points on the graph to see if they land on that line. So 3, 2, 1, 3/2. So it's 1, and the y value is 3/2, and -1, 1. So 3, 2. Now look at how these axes are marked. This is 1 here, so this is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, and the same along the x-axis. So this is 3, and this is 2 right here. This is 1, and this is 1/2, 2/2, 3/2. So both of these points fall on this graph, so they are both solutions to that equation. And this is -1, +1 right here. So A, B, and C all are solutions to the equation. They all fall on that graph. And there are 2 solutions to the equation. Well, right here it shows you there are 3, but actually there are infinitely many solutions. So it's every point on this line, and there's an infinite number of points on that line. It goes on and on and on and on. And so E is the correct answer here. And then finally, it's just a question of which equation matches that line, which is the equation of the line. And so if you remember this form, this is the slope. So 1/4 x, or is the slope 5/4? And this is the y-intercept, where the line crosses the y-axis. Does it cross at the point y equals 5/4 or y equals 1/4? So the slope, you can look at a number of different places. If you go out here and you just count 1 unit to the right, so for 1 unit in the x direction, how many units does it go up? In the y direction, it goes up 1/4 of a unit. That means the slope is 1/4 over 1. The length in the y direction is 1/4. The length in the x direction is 1. So for every unit, the line increases 1/4 of a unit, so the slope is 1/4. And where does it cross the y-axis? What's the y-intercept? Well, this is 1/4, 2/4, 3/4, 4/4, 5/4 right here. So that equation is y equals 1/4 x, this is the slope, times x. So for every unit x, y is 1/4 of that unit x. So this y is 1/4 of this length right here. And then you have to add the 5/4. So there's 5/4 in the beginning. So y equals 1/4 x plus 5/4. So y equals 1/4 x plus 5/4. And what they did in the last equation is they just switched these numbers. They switched the y-intercept and they switched the slope. So this is not the correct equation. It might be interesting to graph this equation. It has a slope of 5/4. So for every unit in the x direction, y is going to increase 5/4 of that 1 unit. So it's going to be 1/4 longer, and it's going to cross the y-axis at y equals 1/4. So you might graph this just to take a look. But the answers are A, B, C, E, and F. So in problem number 5, it says a participant in a 21-mile walkathon walks at a steady rate of 3 miles per hour. So I'm going to be the participant in this case. So if I'm walking 21 miles in a walkathon, I think that I can represent that relationship on a graph as a straight line with a slope of -3. And so do you agree with me or not? I think I'm going to graph it on a line. It's going to be a straight line. It's going to have a slope of -3. So if I start out, number of hours walked, so if I start out 0 hours, I have 21 miles remaining. I've walked 0 miles. I still have 21 miles to go. Remember here it says number of miles left to walk. So that's miles remaining. So if I walk for 1 hour, I've walked 3 miles. I have 18 miles left. I walk for 2 hours. I've walked for 6 miles. I have 15 miles left. So what's the relationship? What's y over x for miles remaining compared to the number of hours walked? So let's just take this first one here. So I have 18 miles remaining. I have to subtract from this 18, I have to subtract the 21 miles that I started at. So 18 minus this 21 is equal to -3. I've walked 3 miles, so 18 minus 21 is -3. So 21 minus 3, or 21 plus -3, equals this 18. How many hours did I take to walk that 3 miles? 1 hour. So I have to subtract where I started from. I started at 21 miles. I only have 18 miles left. So how many miles did I walk? I walked 3 miles, but that's a -3 miles because it's 18 minus this 21. So 21 plus -3 gets me to 18. 18 plus -3, by the way, gets me to 15. And I walked that distance in 1 hour. So a -3, this difference right here is -3. In 1 hour is a slope of -3. So that's the end. So for every hour, you remove 3 miles from the number of miles remaining. So you walk 1 hour, that's a -3 miles. Walk another hour, that's a -3 miles. Walk 2 hours, that's a -6 miles. So 21 plus a -6 is 15 miles remaining. So 15 minus this 21 equals -6, and you will have walked that in 2 hours. A -6 divided by 2 in every 2 hours, or per 2 hours, is going to give you the same amount per hour, -3 miles per hour. And so I'm interested, so that's actually the end of the problem. So you could stop there, but I'm interested in writing the equation, reviewing these things a little bit, and actually going way beyond this. Why do you always end up with this same equation, no matter where you start and no matter where you end within the context of this problem? Why do you always end up with y equals -3x plus 21? This is the slope-intercept form of the equation, and you can write the equation for this line in this problem in this form by knowing that you know that the slope is -3. We've already calculated that. So m is the slope, that's -3. So y is equal to -3 times whatever the time is that you've walked. And that's going to be added to 21. So effectively, that's taking this number of miles away from 21. And 21 is the y-intercept. You know that in 0 hours, you have 21 miles to walk. That's the y-coordinate, or the y value. So the y-intercept is 21. So this is the equation for this line in this problem. Slope -3, y-intercept is a positive 21. Begin at 21 miles, subtract 3 miles each hour. So y equals -3x plus 21. So let's go back to here. So you're going to begin at 21, subtract 3 miles each hour. So to write this equation, so you have to figure out what is the length along the y-axis compared to the length along the x-axis. The length along the y-axis, you subtract where you started. So this is 18 minus 21. So what's that length along the y-axis? And you can see this in the graph. I'm going to take these 18 units where I ended. I'm going to subtract where I started. So this 18 right here minus this 21, this triangle is going to slide all the way down here. And so what's this length along the y-axis? This length along the y-axis is a -3 units. And so how long did it take me to remove those 3 miles from the number of miles I have remaining? It took 1 hour. So it's a -3. This length along the y-axis is -3 divided by the 1 hour it took me. So that's going to be a slope of -1. Now to figure out the equation, you subtract from the ending amount. So I end wherever I end, x, y. Wherever I end on this, I go out x amount of time, I end at y number of miles remaining. Go out x amount of time, I end up at y number of miles remaining. Wherever I am on this line, I'm always going to subtract the starting point. And the starting point in this case is 0.21. So it's going to be y minus the starting point, which is 21. So I have to take that 21 miles away to figure out how many miles I've walked. And I have to take the number of hours away to figure out how many hours I've walked. Well, I'm starting at 0 hours, so I don't have to remove any hours. The x-coordinate, the number of hours, is the x value. And what that says is that the length along the y-axis is a -3 times the length along the x-axis. So if the length along the x-axis is 1 unit, the length along the y-axis is a -3 times that. So you have to, the length along the y-axis is a -3 times the number of hours walked. And you have to add the beginning amount. You have to add this 21 miles back to figure out how many miles are left to walk. How many miles remain? That's y. So you have y plus a -21 equals a -3x. So this -3x is the number of miles you walk each hour. That gets subtracted from 21. Well, you have to add that 21 there. So the equation becomes y equals, so this is the number of miles remaining to be walked, equals -3 times how many hours you've walked, plus 21. So that 21 is your starting point, and you're going to gradually take miles away from this 21. And this is hard for me to explain. I think it just takes practice, and it takes problems in different contexts. Same idea, but just different stories or different contexts to continue to develop an understanding of this. But let's go on. Instead of starting at 0.21, what if I walk for an hour and then I rest? And then I start up again. So now I'm going to start at 1:18 instead of 0.21. I'm out here, I've walked 1 hour, I have 18 miles left to walk, and now I'm going to start up again. So now I'm continuing to walk, and I have to get this equation, I have to take the amount that I'm starting with and take where I'm left, where I end up, and subtract that 18 miles that I started with. So y minus 18 to get this length, but I also have to add back the 3 miles from the 1 hour I've already walked. I've already walked 1 hour, so I'm going to subtract that 1 hour. And I'm going to multiply that 1 hour, it's right here, times the 3, remember it's 3 miles for every hour walked. So I have to add that back. That has to show up as a positive 3 miles because this whole total distance has to be 21 miles. So it's 18 plus this 3 right here equals this 21. So the number of miles I have remaining to walk is equal to -3 times the total number of hours. So I rested for an hour, and then I continued to walk. And so now the total number of hours, I have to add back that 3 miles for the hour that I rested. That's right here. And so the total time that you've walked, that has to times the 3 miles for each hour, it gets subtracted from the original 21 miles. Hard to talk through. Hopefully you're starting to see what's going on. We're going to go through a few more examples, and hopefully this will make more sense to you as you do that. Right, in every case, as you figure out these equations, imagine that you're sliding the slope triangle from this point, the starting point, down to the origin right here. So let's say that instead of starting at, or actually, instead of ending at 1:18, so 1 hour, 18 miles left to walk, let's say that you end at 4 hours, so you've walked for 4 hours, you have 9 miles left to walk. Well, how many miles did you walk? You walked 9, and you have to subtract the 21 miles that you started at. And so how many miles did you walk to get to here? You walked 12 miles. That's a negative 12, because you've already walked 12 miles, and it took you 4 hours to walk that 12 miles. So here you get the same slope, negative 3. And if you use this point to write the equation, or this idea that wherever you are on this line, I'm going to use that to write the equation starting at 0.21, look what happens. You go back to whatever the y value is, minus 21. So wherever you are on this line, because you're starting here, you have to subtract that 21. So it's y minus 21 over x minus 0. So again, wherever you are on here, because you started at 0, you don't have any time to take away. You don't have to subtract any time. So you're left with the equation y minus 21 over x, and that relationship is a negative 3. So y minus 21 is a negative 3 times whatever x is. And that makes sense. The number of miles that you have remaining to walk is a negative 3 times the number of hours you've walked times the number of hours you've walked. All right, so you have y plus negative 21, and you have to add this 21 miles back because that's where you start. And so whatever the total time is, that gets multiplied, that you've walked, that gets multiplied by negative 3, because it's 3 miles for each hour that you walked, and you're going to subtract that from this 21. So again, you end up with the same original equation. Now, what if, instead of starting at 0.21, what if I start at this point here, 4:09? So I walk for 4 hours, I have 9 miles remaining to walk. So I rest for a little while, and then I start up again. So now I'm starting at 4:09. So if I start here at 4:09, and I end at 6:03, this is 6 total hours. But from this point, how many hours did I walk? Well, I walked for 2 hours. That's the 6 minus 4 is 2 hours. And how many miles did I walk in that amount of time? Well, I have 3 miles remaining. I started with only 9 miles remaining. So the distance I walked is that 3 minus that 9 is negative 6. So I walked 6 miles. It took me 2 hours to walk that 6 miles. So the slope is negative 3 once again. Now, how do you write the equation using these points? Well, you're going to subtract where you start. So y minus 9. So I need to get this point here. I need to subtract these 9 miles from the 3 miles. So wherever I am along this line, I'm going to subtract 9 miles. So this is going to slide down 9 miles. So y minus 9. And I already walked 4 hours to get here. So I walked these 4 hours. So you have to subtract. They have to take that away. So notice that 4 hours that you walked times the 3 miles for every hour, that equals 12 hours. Or I'm sorry, 12 miles. All right, so here, y plus negative 9. So I'm going to have to add back these 9 miles that I already walked, that I have remaining, and plus the 12 miles that I already walked. Well, how does this positive 12 show up? Well, you have to look at the opposite of the 4 hours. So that's a negative 4 hours times the opposite of 3 miles for each hour. So this shows up as a positive 12. So you have to add positive 12 plus the positive 9 miles. You have 9 miles remaining. You've already walked 12 miles. that 9 miles remaining plus the 12 miles you've already walked. What does that equal? That equals 21, the total 21 miles. So right here, using this equation, this is the total time walked. It's not just the 2 hours here. It's, if you go to this point, it's a total of 6 hours to get to this point, regardless if you walk this all at one time or if you walk this far and rest and then start up again and walk this far. So if you start up again and walk this far, it works out to be another 6 miles in 2 hours. But the total time is a total of 6 hours. And you have 3 miles remaining, because 3 times 6 is 18 miles. You've already walked 18 miles. You have 3 miles remaining. That's 21 miles left. All right, so notice that if you start at 0 miles, you have 21 miles left to walk. If you start at, this is 0 hours. If you start at 4 hours, you have 9 miles left to walk, because this 4 times 3 miles each hour is 4 times 3 is 12. That 12 plus 9 is 21. Go back to this equation a while ago. You walk for 1 hour, that's 3 miles. 3 plus 18 is 21 miles. So you have to add back these 3 miles that you already walked for that 1 hour. So here's the 3 miles that you've already walked, plus this 18 miles that you have remaining. That 18 plus 3 is equal to this 21 miles. So regardless of how far you've walked, whether or not you've walked for 1 hour and rested and then started up again, which is what this problem shows, or you walk the whole distance in one without resting at all, that's what this equation is. This is whatever the total time is times -3, and you subtract that from this 21. Whether that total time is 1 hour plus some more time. Now let's continue to look at this. So here I zoomed out a little bit so you can see the movement of every one of these slope triangles to get to the origin. So as you figure out the slope and as you write these equations, imagine slope triangles moving. This pink triangle moves from this point here, 0, 21, to the origin. This orange triangle moves from 0, 21 to the origin. So this tells you that when you make that move, you're doing that calculation to tell you that this is -3 miles, or this is -12 miles, or this is -6 miles. So -3 miles took this 1 hour, -6 miles took this 2 hours, and the -12 miles took these 4 hours. So this gets to writing the equation in the standard form. So you might remember this from a while ago. So however many miles you've walked, that's 3 times the amount of time. So 1 hour, 3 miles, 2 hours, 6 miles, 3 hours, 9 miles, 4 hours, 12 miles. However many miles you've walked, plus the miles remaining. That's why that sum always has to equal 21. That's why this graph is the way that it is. It takes this form. The sum is always this 21 miles. So let's look at a few more examples. Let's go back to starting at 0, 21 and ending at 2 different points, 118 and 4, 9. So 118, this is 3 miles plus this 18 would be 12 miles. This is 4 times 3 is 12 miles plus this 9 is 21 miles. So 12 plus 9 is 21. 3 plus 18 is 21. So notice that whichever one you choose, since you're starting at 0, 21, you write the same equation. Y minus 21 over x, y minus 21 over x. But if you start at 4, 9, if you start here and then go to this point, then it looks different. It's, first of all, this is 3 times 6 is 18 miles, plus these 3 miles here is 12 miles. You have to get rid of these 9 miles here. So 3 minus 9 tells you that you have walked for this length is 6 miles. So this is a -6. And you've walked that 6 miles in 2 hours. So it's this 6 minus this 4. So you have to get rid of these 4 hours here, and you're left with these 2 hours. So 6 minus 4 is 2. Now, wherever you are on this line, if you start at 4, 9, you have to subtract the 9 miles. So y minus 9, and you have to subtract these 4 hours. So x minus 4. So in this case, it always equals -3. That relationship is -3, and it's -3 over here as well. But this is y minus 21. So remember, you have to add that 21 miles back right here. And this is the amount of time that you've walked times the -3 miles for each unit time. Over here, and it's the same here. So you're doing the same thing. Y minus 21 over x. Y minus 21 is equal to -3 times this amount. This amount is a -3 times longer than the length along the x-axis. All right. So over here, this is still equal to -3, but now, since you're subtracting 9, you have to add this 9 back. But you also have to include the 12 miles that you've already walked. Where does that 12 miles come from? This 12 miles is the 4 hours here, and you walked for 4 hours. This is 12 miles. From 21 to 9 is 12 miles, and that sum, that 12 plus this 9, has to equal the total 21 miles. So you have to add that 12 miles back. So this is the opposite of 3 times the 4 hours you're adding back. So it's the opposite of that 4 hours. So -3 times a -4 is positive 12. So you're going to add back 12 miles plus the 9 miles that you have remaining. That sum has to equal 21. So you add this 9 to this 12, and you end up with the same original equation, because the total time here, they don't know where you start. They don't know where you end. It's just the total amount of time from the very beginning to get to whatever point you are on this line. That's what this x is. Because as you go out here, that's what x tells you. I've walked for a total of 5 hours. I've walked for a total of 6 hours. I've walked for a total of 7 hours. So the equation turns out to be the same. So 9 miles remaining, took 4 hours to get there. So a total of 12 miles. So 9 miles remaining, this 9 right here, took 4 hours to get there, to get to this point right here. So that's 12 miles. So that total is 21 miles. And then you walked another 6 miles. That's what this line is right here. Another 6 miles. So now you have 3 miles remaining. So the total amount of time that you've walked out to this point is 6 hours. So you've walked 18 miles. You have 3 miles left. Walked another 6 miles. 3 miles remain. Took 2 more hours plus the 4 hours to get there. All right, now let's change this up fairly dramatically, and let's use some fractions. So if I go out here 5.5 hours, so halfway between 5 and 6 hours, 5.5 hours, how many miles do I have remaining in my walk? Well, that's going to be halfway between 3 miles remaining and 6 miles remaining. If I walk for 6 hours, I have 3 miles remaining. If I walk for 5 hours, I have 6 miles remaining. Well, halfway in between 3 and 6 is 4.5. So this point right here, you walk for 5.5 hours, you have 4.5 miles remaining in the walk. So to figure out the slope using this point, and let's say that you start here at 4.9, how far have you walked? Well, you have 4.5 miles remaining. You started with 9 miles remaining. What's that difference? It is a -4.5 miles traveled. So how far did I walk? I walked 4.5 miles. And so that's, I took off 4.5 miles from this original 9 miles. So 4.5 minus this 9. And how long did it take me to walk that 4.5 miles? It took me an hour and a half. So this 5.5 hours minus the 4 hours here means I walked this 4.5 miles in 1.5 hours. So what's that relationship? What's that ratio? What's the slope? It is the negative 9 halves. This is a negative 9 halves. 2 times 4 is 8, plus 1 is 9 halves, divided by 3 halves. 2 times 1 is 2, plus 1 is 3 halves. To figure that out, you use the inverse operation, which is multiplication, and you use the multiplicative inverse, which is 2/3. Factor out this negative 9 here into negative 3 times 3, and then times this 2. Use the commutative property to rewrite this as 3 times 2. So these 3's cancel, these 2's cancel, and you end up with this same negative 3 as a slope. And if you look at the movement of the slope triangle, you're figuring out this length by subtracting these 9 units from 4.5. You do that, the slope triangle is going to move down 9 units, so this length is going to be a negative 4.5 right here, negative 4.5. And then as you subtract these 4 hours from 5.5 hours, this slides over. So this length right here is going to be 1.5 hours. So now you've measured this length as equal to negative 4.5 units, miles remaining in this case, and it took you 1.5 hours to walk that. So now if you use this to write the equation, notice you're going to write this same form right here. You start at 9:4, so 4 hours, 9 miles remaining. So you subtract the 9, subtract the 4 hours, so subtract this 9, subtract this 4 hours wherever you are. Subtract the 9, subtract these 4 hours right here. And this works out. You have to add these 9 miles back. And you have to include the 12 miles that you already walked. That's this negative 3 times negative 4 is the positive 12. Add the 9 miles, and you get back to this original equation. Y equals negative 3x plus 21. So this is a lot. I probably have messed up this explanation and went into too much detail. I'm not sure if I'm being all that clear. I think it just takes more examples, more attempts at trying to explain it. The issue is the attempt at trying to explain it. It has to make sense in some way. So we'll look for more of these in the future. I'm not sure what the authors do, but we'll just move forward.